Hello everyone, welcome to Algo Ramster. Today we're going to discuss about the important interview questions on operating system. Let us start now. First question is what is an operating system? So what is basically operating system? Operating system is a software program that facilitates computer hardware to communicate and operate with the software by being the intermediate layer between hardware and software. It's basically operating system is a software program that facilitates computer hardware to communicate and operate with the software by being the intermediate layer between the hardware and software. Okay, next question is what are the main functions of operating system? Let us discuss the main functions of OS. It makes sure that an operating system acts as a manager, performing well by managing its computational activity. And also it helps in execution of programs like memory management and device management as well as file management too. Okay. So what is demand paging? You know that what is demand paging? Whenever any process page is demanded, the CPU looks in RAM first, that is in main memory, and if not found, the OS brings the missing pages from the disk, that is secondary memory, into the RAM, that is primary memory. So this is a lazy evaluation as only those pages are swapped which are demanded by the process from the secondary memory to main memory. As we discussed, okay. So what are the different types of operating system then? There are many types of operating system. Let us see one by one, that is distributed operating system, batched operating system, and real-time operating system, time sharing, and multi-program. Okay, so let us discuss another one. That is what is kernel basically. A kernel is considered the most critical part of a computer operating system, acting as a heart of operating system that provides OS essential service, I can say. It's basically do the more critical services of the operating system. With the operating system, kernel is also loaded into the memory and remains in the memory until the operating system is not shut. We got that, and it performs various tasks such as memory management, risk management, and task management. Okay, hope you got that. And let's see what is critical section basically. What is critical section in operating system? The critical section problem is an important issue to consider when designing operating system. It is basically important issue, and there are a number of ways to prevent the critical section problem from occurring. One is to have each process wait until the other has finished its critical section before starting its own. Another is to have the operating system check for conflicts and give priority to one process over another. So this is basically critical section problem, I can say. Okay. And what is virtual memory? Virtual memory is memory management technique for letting the process to execute outside of memory, as we said. And this is very useful, especially if an operating system, that is, if an executing program cannot fit in the physical memory. You got it? And virtual memory is basically volatile memory. We can say RAM like that, that is temporary memory created on the storage drive. Usually, when we open many applications or work on those applications, the RAM is required to execute these applications. But if RAM is low, still you manage to work on those applications. Oh. In that case, the operating system takes part of secondary device, that is secondary storage, which will now act as a RAM until the processes are running. Got it? It's basically illusion to the user that it is showing large memory, but the thing is, it is using secondary storage for extension of memory. Okay. What is deadlock? So let us see what is deadlock basically. Deadlock is blockage situation, I can say. Blockage situation where each process is waiting for another resource that is acquired by some other process and is holding a resource already. It's basically one process is waiting for another process, another resource, and that resource is holded by another process which is waiting for another resource. It's basically circular deadlock kind of, and in short, they are waiting for another process to get finished and release the resource. As I said earlier, and consider an example, like real-time example when two cars are coming toward each other on the same track and there is only one track, none of them can move. They are in front of each other. These two cars will be in deadlock situation. Okay, so let us see what is thread. We know that what is process. Process is program under execution. So what is thread basically? A thread is lightweight process having some of the properties of process. A single process can have different threads, and threads introduce parallelism and improve the application through it. For example, multiple tabs can be different threads in a browser. MS Word uses multiple threads, and one thread is for formatting the text, another thread is to process inputs, etc. So this is basically thread. Okay. So what are the necessary conditions for deadlock? So we know that we got to know that what is deadlock. Deadlock is basically one process is waiting for another resource which is holded by another process. And what are the necessary conditions for deadlock basically? So mutual exclusion, hold on wait, and no preemption and circular wait. These are the four conditions for deadlock to be happen. I can say what is mutual exclusion means only one process can use a resource at a time. That is non-shareable resources. Okay, hold and wait means when a process holds at least one resource and waits for other resource, that is hold and wait. Okay, no preemption means it's basically non-preemption, I can say. Unless the process releases the resource itself, no other resource can inform it. Okay, and circular wait. It's basically, I said earlier, that is a set of processes wait for each other in a circular turn. It's basically circular kind of deadlock. Okay, so okay, what are the examples of operating system? Like we know what is operating system, know the main functions of operating system, but what are the examples of operating system we use daily? We can see that Windows is one of the example we use daily, like so many people using daily, and MS-DOS that is too old, but some of them may use this kind of operating system. Linux, Linux is actually good in terms of doing some Linux-based commands, we can say. And for example, macOS actually uses Linux-based command itself, and Android is basically every person have their Android phones in their pockets or in their hands, I can say. And iOS, it's another operating system which is specifically for Apple. And okay, so what do you mean by process? Okay, we got to know that what is thread. Thread is basically lightweight process. So what is process now? A program, when executed, is known as process. We know what is program now. Program is basically set of instructions. Okay. So when it is executed, we can call that as process. Okay. So these are the two types of process. Okay. User process and operating system process. Operating system process means it's basically hardware process. And user process means the user executing the program, I can say. Okay. So what are the different states of processes? I can say. So there are five states of processes, that is new state, ready state, and ready suspended state, and running state, and waiting or blocked state, I can say. So these are the five states of a process. So let us see one by one. That is new state. New state, as name only suggests, that it is the first state of a process. This is the state where the process is just created. That is the state where new state is called. And ready statement, as name suggests, if the process is ready to be executed, then the process is in ready state. Okay, ready suspended state means sometimes we know that when many processes come into ready state, then due to some memory constraints, some processes are shifted from ready state to ready suspended state. So that type of state is ready suspended state. And running state. Running state means, as name only stated, when process is running from ready state to the running state, we can say that there is running state. That is one process from the ready state queue is to put into the running state queue by the CPU for execution, and the process will be now in running state. Okay, waiting state or block state, I can say. If during execution the sum of the processes wants to execute or want to do IO operations like writing one file or some more priority process might come, then the running process will go in the blocked state or waiting state, I can say. Okay, what is the advantage of multi-core operating system? I can say multiprocessor operating system, I can say. What is multiprocessor systems means? It's like basically using multiple processors, like multiple CPUs for execution. Like multi-processing systems have different processors perform different tasks. Okay, if the system has more processors, there will be considerable increment in throughput. What is throughput means? Number of processes executed per unit time, I can say. So it is cost effective and also reliable. Also because they can share resources among other tasks. Okay. What is trashing? You know what is trashing means? Trashing is the state in which virtual memory scheme when the processor is not doing any work other than executing instructions instead of spending most of its time in swapping pages. So it's basically rather than executing the process, it is involved. The process involved more in swapping from main memory to secondary memory and secondary memory to main memory. It's basically involved in more. Most of the time is in swapping process rather than executing its process, I can say. So data is rapidly exchanged on the hard disk. Tracing basically happens as the main memory gets filled, so additional pages should be swapped in and out of the virtual memory. This causes high hard disk access. It can lead to collapse or it can lead to the collapse of hard drive of the computer. Okay. What is RAID or RAID? What are the different RAID levels? It's basically uh, what is RAID means the redundant array of independent disks. That is basically right. It is basically used to store the same data redundantly to improve the overall performance. We can say that data redundancy, data redundancy. So it's basically useful for backup kind of, or data stability kind of. And what are the different levels means RAID 0 and RAID 1 and RAID 2. RAID 2 is not there, RAID 3 and RAID 5 and RAID 6. Okay, so what is RAID 0? Okay, stripped disk array without fault tolerance is RAID 0. In this, data is stripped between different disks, and you can access data it offers the most, or it offers the best performance, but it does not provide fault tolerance, I can say. It does not provide fault tolerance because it basically stripped between, you can say, stripped between different disks, I can say. Okay, so what is RAID 1? That is mirroring and duplexing. What is mirroring? This basically provides fault tolerance. In RAID 0, it does not provide fault tolerance, but RAID 1, fault tolerance will be there, and it is also stored in different disks. And if one fails, then data can be accessed from the another drive, that is only fault tolerance. And RAID 3, there is no RAID 2. I don't know why, but what is RAID 3 means bit interleaved parity, I can say. RAID 3 is not used much, but data is divided evenly and stored on two or more disks, I can say. Plus, there is a dedicated drive for parity storage, I can say. And RAID 5, that is a block interleaved distributed parity. Data is basically divided evenly and distributed, stored on two or more disks, I can say. Plus parity. You got it one by one level. It's improving in the redundancy, I can say. Okay, RAIDs is also data is divided evenly and stored on two or more disks. Plus parity is distributed in two different drives. This is two different drives, and RAID 5 is only one different drive. Okay. What is Banker's algorithm now? Banker's algorithm is basically deadlock avoidance method. It is named on the banking system, where the bank allocates the available cash in such a manner that it can satisfy the requirement of all of its customers by subtracting subtracting the loan amount from the total amount of money the bank has. In the same way, in the operating system, they included that when a new process is to be executed, it requires some of the resources. So banker's algorithm needs to know how many resources the process could possibly request. How many resources are being held by processes? How many resources the system has the and accordingly resources are being assigned if available resources are more than the requested resources in order to avoid deadlock. Hope you got it. And what is Bellardi anomaly? Bellardi's anomaly. You know that first in first out page replacement algorithm, that is whoever comes first will give more priority for that kind of page or that kind of process. Okay, what Bellardi's anomaly means, it's a basically anomaly with some replacement policies where on increasing the number of frames, there is increasing number of page faults, I can say. Okay, it's basically page frames are directly proportional to the page faults. This is basically Bellardi's anomaly, and it occurs when FIFO page replacement algorithm is used. Okay, okay, so what is primary function of paging? We got to know that what is demand paging and what is basically that what is function of paging, I can say. To solve the problem of internal or external fragmentation, we can either compact the memory, making the large free memory blocks, or implement paging scheme that allows programs memory to be non-contiguous, thus permitting a program to be allocated physical memory whenever it is available. You got it? So paging is memory management scheme that removes the requirement of contiguous memory allocation. Okay, so what is and difference between logical and physical address space? Oh, what is logical address space and physical address space? Logical address space is a virtual address generated by CPU. As name suggests, logical address means logic related uh, will be always done by CPU. So logical address is basically virtual address generated by CPU. And physical address, what is physical address means? A physical address is generated by MMU, that is memory management unit. So memory management unit only will generate a physical address, that is hardware unit, I can say. It is basically in the case of logical addressing, it is the address of data or instruction used by the program. In case of physical address, a physical address is a location in the memory mapped to the corresponding logical unit, logical address, I can say. So it basically mapped to the logical address, and it's not visible to the user in case of logical address, and physical address as it's physical, then it's visible to the user. Okay. Okay, what is multi-processor system and what are the advantages of using it, I can say. Okay, when a computer hardware, that is computer system, has two or more CPUs, all CPUs have share RAM, because RAM cannot be assigned to each of the CPU, right? So it basically shared the all CPUs so shared with the RAM. I can say all CPUs share RAM, and this system is also known as tightly coupled or a parallel system. Tightly coupled, you know that it's basically dependency will be there. Okay, so loosely coupled means there is no much dependency will be there, and the process is divided into different subprocessors, and other processors get different subprocessors to work. Now, what are the advantages of multiprocessor system means? It's basically increased throughput and reduced cost and increased reliability. So these are some of the advantages of multiprocessor system. What are the main advantages or functions of file management in operating system? Okay, main functions means creating and deleting files, obviously, and providing I/O support for multiple users. I/O means input output. In the file we can give input and it can we can give or we can store the output too, and ensuring data in the file is correct, and it's basically consistency or integrity, and backup and restoration of files on storage media. And for backup also we can store some of the information, some of the sensitive information we can store in the into the file, and we can for storage of backup, I can say, and tracking data location, and we can track the data location for each type of different type of data, and storing data. It's mainly used for storage purpose. Okay, so what does device driver mean? What is device driver basically? It is a software application that allows a computer's operating system to communicate with each other's peripheral devices such as printers, sound cards, and graphic cards, etc. In short, basically, it facilitates communication between two devices. Okay, so it's basically short, or you can say it facilitates communication between two devices, that is printer and sound cards and graphic cards. It's basically communication between those. Okay, what is cache memory? Primary memory, that is RAM, secondary memory, that is disk. But what is cache memory then? Cache memory is a small sized memory that is volatile, that is temporary, and that means its contents are stored temporarily. While cache memory is small in size, so it is faster than main memory and secondary memory as its size is small. So accessing the data from cache memory is fast. We know that accessing data from cache memory is always fast. And whenever the CPU wants to access any data, it first checks the cache memory. And later, if it is not there in the cache, then the CPU goes to the main memory. Okay, what is spooling? The full form of spool is simultaneous peripheral operations online. Okay, in spooling, the data is gathered temporarily and executed by the program or device. For example, in a printer, we give different printing commands to printer here, and spooling keeps all the jobs into a disk file and queues them in the order these printing commands were received. Spooling is basically based on first in, first out principle. This means the request that comes first will be processed first, and the request which comes later will be processed after that. Okay, what is multiprogramming and what is its main objective? So we know that what is multiprocessing or multiprocessor system, but what is multiprogramming here? Multiprogramming, multiprocesses are loaded into its main memory. Okay, and the operating system picks tasks one by one and start executing them. Okay, one by one, it basically pick and start executing them. Okay, and the following processes from the job pool is picked up when the program is not getting executed or requires IO. In the case of multiple jobs in a ready state, which job is to choose is decided through CPU scheduling. Okay, it never leaves a CPU idle and maximizes CPU usage. Okay. And what are the objectives of multiprogramming? Means it manages the resources of a system. A multiprogramming operating system can execute multiple programs using only one processor system or one processor machine. Okay. So explain the booting and bootstrap program in operating system now. We know that what is booting. Booting is basically like starting the computer. We know that what is the exact meaning of that. When the computer is turned on, some initial programs are required to run. Yes, for starting the computer or the desktop, we need some of the programs, I can say, initial programs are required to run. These initial programs are called bootstrap programs. And these programs are stored in ROM or EEPROM, I can say. Bootstrap program will load the kernel into main memory. Okay. First, initially, bootstrap programs will run basically, and after running the program, those programs, it's basically load the kernel into RAM. Okay. The process of loading kernel itself is called booting process. Okay, you got it. So explain compaction. We know that what is phasing. We got to know that. Now, what is compaction? The free space is broken into different pieces. When processes are loaded or removed from the memory, the sum of the free space is broken into different pieces. These free spaces are there in scattered way. So to store the process, we need to compact these scattered pieces of memory to form large chunk of memory in case of any large processes comes in. Okay. It's basically to store the processors, we need to compact these scattered pieces of memory to form large chunk of memory. That is, we need to compact these pieces to form large memory so that we can use that memory for later purpose. Okay, that is basically compaction. Okay, what is different between page and frame? We know what is paging and also we know what is frame. But what is different between that? So let us see. Programs are stored on secondary storage, that is hard disk, which is divided into fixed size blocks called pages. Okay, programs initially stored in secondary storage and which is divided into fixed size blocks, that is pages. And in the same way, main memory also is divided into some of the blocks of same size as pages, like divided in the secondary storage, that is called frames. You got it? So the page is smallest unit of memory managed by the computer's operating system, either in physical form or virtual form. Okay. So in short, we can say physical memory is divided into frame and logical memory is divided into page. Okay. So what is context switching? We know that what is context switching. That is, we'll get to know what is context switching in a while. Like, it is the process of switching the CPU from one process to another. We know that from one process, when some interrupt or some function is calling that process, it basically preempt the one process to another process. Suppose the CPU is executing a program in the suspended state by the CPU, and the CPU executes another CPU present in ready state. This switching is so fast that it gives an illusion of simultaneous execution of process by the CPU. In this case, the whole process state is saved before loading the new process. Because after executing new process, if when the process is returning back to the another state, that is old state, at least we need to store, right, like in the some of the data structure kind of, that is we can use stack, that is apart from this. But one thing is to remember is that no work is done during context switching. Okay, it's basically context switching, uh saving present state and switching back to the new state. That is basically context switching. Okay, how is the memory management done in operating system? We know that what is memory management and what are the techniques involved in this, that is paging and virtual memory and demand paging. There are so many, we got to know that. And now, what is memory management? Or like, how is the memory management done? Memory management is the primary function of operating system, which is responsible for coordinating and controlling the computer memory by doing the following: storing the program in specific locations, okay, keeping track of which program is allocated, and keeping track of how much memory and which memory allocated, that is location is allocated, and tracks free memory status, that is which is free space is there, and accordingly allocate the memory to the another process. It also ensures that another process should not corrupt memory or allocate the process. Okay, what is explained round robin with an example? We know that there are some of important scheduling algorithms, these process scheduling algorithms in this. One of this is round robin. So the round robin algorithm is an scheduling algorithm that is often used in operating system. The basic idea behind the algorithm is to give process with a fixed amount of time to execute and then move to the next cycle. This ensures that all the process get a fair share of CPU time. This fair share of time is all time slice. Okay, this is the example. Okay. Suppose we have three processes A, B, C that needs to be scheduled. We give each process as time slash as 2 seconds. Process A gets to run for 2 seconds, then process B gets to run for 2 seconds, and then process C gets to run for 2 seconds. After that, we start again from process 2, process A. This ensures that all the process get a fair share of CPU time. So this is more efficient algorithm, I can say. And okay, how to prevent deadlock? You know, what are the necessary conditions of deadlock? That is mutual exclusion, hold and wait, no preemption, and circular wait. So these are some of the necessary conditions to deadlock for deadlock, I can say. So how we can prevent deadlock using these conditions? So when you have say shareable resources, there will be no fight for resources, which will prevent for deadlock conditions. Okay, so for hold and wait in this condition, a process holding resources is waiting for other resources, but there are ways to eliminate this condition. That is, when a process beforehand specifies the resources it requires. In this way, the process doesn't have to wait for allocation. By releasing all the resources the process is currently holding and then making a new request. Okay. And if the process releases all the resources, then that can lead to the problem, as there will be some processes that are not carried by any other process. Okay, no preemption. It's basically non-preemption kind of. Preemption means temporarily interruption of program execution. Normally, processes can't be preempted. Suppose some of the processes P1 wants a resource R1 held by process P2. This situation lead to deadlock state, but to avoid deadlock, the process P2 is preempted and resource R1 would be released and given to process P1. Then we can prevent deadlock. No, this can lead to inconsistent state, I can say. What is circular weight? You know that what is circular weight means? We can eliminate this circular weight. Okay, wait a minute. Okay, what is circular weight means? We can eliminate the circular weight condition by giving priority to its resource. A process accesses the resources in the increasing order of priority. If a request is made for a low priority resource being held by some other resource, the request will be considered invalid, I can say. Okay, so this will be one of the uh, conditions for preventing the deadlock, I can say. Okay, so these are some of the important interview questions on operating system. Hope you liked it. So share, like, and subscribe to Algo Star for more videos like this. And hope you liked it. Thank you, and see you for next video.